a certain output, or let's go further. As is. Let me see if I can show you. Okay, so now suppose we have some hidden layer over here. Right, in a hidden layer, remember we have some activation function, then another activation function. Another activation function, right? So suppose this is your hidden layer. So what we want to do is we want to randomly, and here's the next layer over here, and of course the weights over here, W in the next layer, right? Okay, so the idea is perhaps randomly we pick, let's say, this one, and we want to zero it out. Okay, if this was producing 0.13, we want to let it go as is 0.13. Another one over here, let's say, was producing 0.71. And we will simply let it go as 0.71. Another one over here, let's say we may want to zero it out. So my question to you is, what will you do to, first of all, if you take a look at the outputs of a network, are they a matrix or are they a vector? Outputs of a hidden any network. So if we have 100 neurons over here, right? Won't the outputs coming out of this will be a 100 by 1 vector? Yes. Everybody agrees? So you are given some let's pretend the output came out to be 0.3, 0.71, 0.92, 0.11, 0.08. Suppose this came out to be 100 by 1. So this is output of the hidden layer. So my question to you is, if I randomly want to zero out some of the numbers over here, what should I do to these numbers? So that few numbers don't get changed.
So you need to multiply it by a vector that has ones and zeros.
Exactly.
Which would be element-wise, not like...
So suppose I wanted to zero out 0.92. And I wanted to let 0.23, 0.1. So if I multiply this by 1, this by 1, but this by 0, right? So a simple element by element product, which in our terminology, mathematical terminology, we indicate by a dot in a circle. So dot in a circle basically means element by element product. Okay, so if you were to implement this in Python as an example, right? I'll show you the code after the break. What you'll see is, if I wanted to implement dropout, and let's say I wanted a dropout to be 80%. When we say 80% dropout, it really means we're zeroing out 20%, keeping 80%. Okay. So it's the opposite way it's specified. So 20% will be zeroed out. So there's a simple function in Python that I'll show you after we come back, where we can create a vector with ones and zeros, and we can indicate randomly what percentage of those should be zeroed out, right? Then all we will do is compute the output of the network exactly like before in a normal way. Just multiply it with multiply this element by element product before feeding it to the next layer. So think of this way in the entire architecture. If these are the outputs going, right? Here, if I create this red column over here, so this is the dropout layer. And it is extremely easy to program, easy to implement, and it is very effective, okay, very effective.
Why?
So the intuition is like this, okay? And by the way, during training, okay, let me also mention this. During training, okay, dropout is used in a random manner. What do I mean in a random manner? For example, oh, I erased it. We are going through one of the epochs, right? We'll create randomly a vector to be multiplied over here. In the second epoch, it may not stay the same. In the second epoch, this may become 0, 1, 1, 0, 1, 0, 1, 1, 1, 0, something like that. So every time it is picking something different to zero out, okay? The analogy would be something like this. Let's say you're an athlete, okay? You get an injury in one leg, right? Then you learn to compensate on the second leg, and your other leg becomes stronger so that you can still function, right? So essentially we are injuring this network so that other neurons try to compensate for it. So they learn that and they become better in recognizing the pattern of the data. Anyway, so like I said, it is extremely easy technique. So rather than, so even for theoretical interest, the weight decay is there, but rarely people use it because dropout will do such a great job. Okay, yes?
Rather than doing dropout, can we categorize weights so that we can create one more neural network or neuron categorization on the other side? So if we get the weight or bias, we get some output, right? Based on the output, we can categorize and we can do the other side of the work.
You mean you'll create
it more accurate, right?
You will create one more network to see if it is overfitting or something? Or
Like, so we have one hidden layer on the system. We'll find out the weights and bias for the output, right?
yeah, without doing any dropout.
Without doing any dropout. So in dropout, we miss some of the data, like 0.05% of data we actually miss it.
Correct.
Rather than doing like that, can we have one more system, okay? So based on these weights, if we get weights into these category, weights and bias into these category, can we put it to the another hidden layer, or it just passes to the output?
I don't think I understood the question correctly. So you are saying don't use the dropout layer here,
Yep.
right?
Yep.
Create one more network.
Yep. If the weight is like less than 0.5, go to the another hidden layer, or else just pass it to the output.
If a certain weight is less than 0.5, go.
That seems to rabbit right.
But see, that may end up hurting the classification. Because we can't simply just go by the size of the weight.
Everything runs on trial and error. So my assumption is like, if the weight should be like after doing all the non-linear system, the weight is linear. like it's a fixed of number for the test data. Right after the number of training, the data, the weights and bias are fixed numbers.
Correct.
Okay, so no matter what the input you give, it responds to the fixed numbers.
But see, the weights are also relative to each other. So there's no absolute number. You cannot say 0.5 as an example. There will be many weights which are 0.0031, 0.0061, 0.0. So if you simply created a criteria, if it is less than 0.005, eliminate those weights. It will end up doing a very poor classification.
But for any test data, these values are same. Bias and weights are same.
Yeah, once it's trained, they do not change.
They do not change.
Correct.
Okay, so it is already perfectly classified, the weights and biases are same. It is defined.
They are fixed. They are fixed, yeah.
They are fixed, okay.
Yeah.
So if we train like, my suggestion is like, can we do like 5,000 data of training data? I'm confused now.
Or we can come back and discuss it during the break. Okay. So anyway, you had one question.
Does a one epoch refer to like one run through of the whole data set?
Whole data set. So if you have 50,000 data set, you will be updating the weights and biases 50,000 times, picking.
That's one epoch.
That's one epoch. And you'll pick the input randomly. So we don't pick it in sequence.
Okay.
So for example, we may pick input number 582 as the first at just the weights. Pick input number 987. So we will go through all 50,000, but in a random order, right?
But you do go through all 50,000.
All 50,000, and that is one epoch. So let me make one comment and then I'll give you a break. So this is a very important concept, and it's related to the nonlinear optimization theory. In the end of the course, we'll come back and go a little bit deeper in it mathematically. Okay. So as far as training is concerned, since we're looking at training, there's a concept called IID. Okay. Identical independent data. So without the IID property, we cannot train a neural network effectively. Okay. So what does this IID mean? Okay. IID. So let me go to each part. So what does identical mean? Okay. Let's say input number 982. Okay. Was class 5. So it's a digit problem. It was a digit 5, right? So it doesn't matter whether it's a first epoch or a 100th epoch. If we ever pick 982, it has to produce 5. If one time the expected output is 5, another time the expected output is 7, network will not train because we are essentially confusing it, right? So that makes sense. Independent over here basically means that, okay, so if I put this loop over here very briefly, for I equal to 0, 2, numi pass. Okay. So for example, as I mentioned, we pick a sample, training sample, and based on this, we compute gradients. And we adjust the weights or biases like W minus alpha delta W of the loss of W, right? Something like this. And similarly, and we keep repeating it over here. Okay. The algorithm, which is defining this, is referred to as stochastic gradient descent. Okay, short as SGD. Okay, so what does stochastic mean? Okay, let's say, like I was giving you an example, through first epoch of the sample that we picked very first time was 982. If in the second epoch, we also pick exact same sequence, okay, it will not train effectively. It will be a very poor result. So stochastic means keep changing the order. So keep changing the order of inputs. So shuffle it each time, pick a different data, then it will train. Okay. And last comment related to IID is, well, let me do this because it will take more than a few minutes. Let me give you guys a break, then I'll come back and clarify the IID because that's an important concept in training of the data.